Hello, everyone, and welcome back to another planetarium show. My name is Jessica. I am the director of the planetarium, and with me tonight are two students who work in the planetarium. Familiar faces if you've been here before, but I will still let them introduce themselves, starting with Lindsay.
Hi, I'm Lindsay. I'm a physics graduate student here at UMD.
I'm Eli. I'm a physics undergraduate student at UMD.
So today, because it's been a while since we have gone out to visit the planets, that's exactly what we're going to do. We're going to go on a quick tour, check out all of the planets, maybe some moons too, while we have, if we have some time. But it's just going to be a fun adventure through our solar system. As always, if you have any questions throughout the show, feel free to leave them down in the comments. Eli is going to keep an eye on those and let me know when questions come up. There will also be time for us to answer questions at the end as well. All right, so let me get everything switched over. If this is your first um, tour of the solar system with us, the program that we use is called Celestia. And it is actually a free program that lets you explore the solar system and some things out as well. If you're interested in checking this out for yourself, I did put a link to the Celestia website in the video description, so you can always go check that out. It takes there's a bit of a learning curve in how to use it, but it's pretty cool. And so that's what we're using today on our exploration. So I've actually started us out kind of far away from our solar system. We're out in the stars. And from out here, it's really hard to see what our sun looks like, which one of these many stars we're seeing is our sun. And that's just really showing how average our sun is. It's just like all of the other stars that are out there. Of course, it's special to us because we are so close to it. So it does look a lot bigger and brighter than the other stars we see. But even as we start to fly into our sun, we know that there's a whole host of things around it, planets, asteroids, comets. But as we make our way in, you can't really see those very well. The planets are incredibly small compared to stars, and they're really, really spread far apart out. And so it's difficult to see them unless you're like right up on the planets. And so what I'm going to do to make it a little bit easier so that we can see where everything is turn on these lines. And these are showing us the orbit path, or the path that the planets take around the sun. So we have our planets, and as we move closer, we see more and more until we end up getting to our sun. And this is where we're starting our tour. Since our sun is what's holding us in place, it is our light and heat and energy. It is an important part of our solar system. And as we've seen, the sun is a star. When we look closely at the sun, which is generally not something you want to do unless you have protective, either protective filters and things so that you don't harm your eyes, because the sun puts out a lot of light, a lot of energy, and without something to kind of filter most of that out, you will destroy your eyes. But looking closely, we see that the sun isn't a smooth ball. In fact, it has these kind of dark spots. These are sunspots. Clever name, right? Spots on the sun. They're a little bit darker because they are a bit cooler than the parts of the sun surrounding it. Not to say that they're cold. The average temperature of the surface of the sun is about 10,000 degrees Fahrenheit. These little dark spots, these sunspots, are about 7,000 degrees, so a little bit cooler, but still very hot. And I call them little spots, but on average, a sunspot is frankly about the size of the Earth. So definitely not little in, terms that we're used to thinking of, but compared to the size of the sun, it's a pretty small spot. In addition, we can also see sometimes these loops of gas coming off the sun. These are what we call prominences, and they are actually loops of gas. It's this gas that's kind of traveling out and then gets pulled back in. But these can also be broken. If that loop stretches out too far, it'll snap, just like if you stretch a rubber band too far. And when it does that, that gas gets flung out into space into what we call a solar flare. So that's where those come from. All right, I think that's enough about our sun. Let's head on to the closest planet to the sun, and that is the planet Mercury. So here we are. No, I did not make a mistake. This is not the moon, although it does look very similar to our moon, and that's because they really are very similar objects. Mercury and the moon are both these small balls of rock that don't have an atmosphere, they don't have really any source of erosion, no volcanoes that are active, and so you just see a dead, geologically dead surface covered in craters. Because those craters, as they hit and leave their mark, there's nothing to erase them because there's no erosion, no volcanic flows, nothing like that. And so once they're pretty much there forever, unless something else lands on top of it and creates another crater on top of it. That's about the only way those really get destroyed. And since our solar system and the planets have been around for 4.5 billion years, that's quite a long time for things to hit, and you end up with lots and lots and lots of craters. Since Mercury is the closest planet to the sun, it does get very hot, daytime temperatures exceeding 700 degrees, but that's only during the day. At night, temperatures can actually drop down to negative 200 degrees. And that comes back to the fact that Mercury doesn't have an atmosphere. Atmospheres act like a blanket, they trap heat. So without that, the nighttime side, once it's no longer being heated by the sun, it gets very cold very fast. And we end up with a super cold night. And so we have this nice kind of dynamic, right, between the incredibly hot days and the frigid nights on Mercury. So heading away from our first planet, the next planet is Venus, which was at one time considered to be Earth's twin. And I actually don't want to talk too terribly much about Venus because we are doing an entire deep dive into this planet next week, next Saturday, as the next part of our exploration series. So I'm going to just say, put a pin in that, come back next week, and we will learn all about the planet Venus, why it was thought to be Earth's twin, and why there's a question mark there now, and what we've learned about it since. So, with that, let's head on to the third planet, which is our home. And of course, this means it is the planet that we know the best, since it's the one we live on and we have, access to study really well. We can also see that it looks quite a bit different than the other two planets that we've been to. It is covered in liquid water. In fact, most of the Earth's surface is covered in this water. And so far, we haven't seen anywhere else in our solar system that has that, at least not today. There's some evidence for things in the past, but I'll talk about that later. And so that makes Earth pretty special, unique among the planets covered in this liquid water. But of course, Earth is also the only planet that we know of that has us, that has life. And that also makes it very unique. Another different thing is Earth is the first planet that we have visited that has a moon. Because Mercury and Venus do not have moons. And so here is our moon up close. As we said, pretty similar to Mercury because there are very similar objects, big ball of rock, no atmosphere, so no erosion, no active volcanoes, so those craters just, when they form, they stick around for a really, really long time. Been around for 4.5 billion years, so lots of craters all over the surface. But one thing we can see on the moon that we didn't see on Mercury are these dark patches. And in fact, if we look closely at these dark patches, you may notice that there aren't as many craters as, say, over here, when we compare it to the lighter gray area, which we see is just covered in craters. When we look at these darker areas, we don't see as many. And that's actually a clue that helped us figure out what these things are. So we call these dark patches the lunar maria. Maria is Latin for sea, a body of water. And that name stems from a time before telescopes, when people looked up at the moon, saw these dark patches, because you can see them with the naked eye from here on Earth. They thought they looked like bodies of water. Well, we know that's not the case. It's rock, but the name has stuck, and so we still call them the lunar maria. But based off of the color of the rock and the samples that we brought back, from all of the Apollo missions, we know that this dark area is actually covered in basalts, lava rock. And so that explains why they seem so much smoother, why they don't have as many craters. These are areas that back early on in the history of the moon, there were active lava flows on the moon. And that lava flooded the surface, filled in the craters that had already formed, kind of like when we fill in potholes in the road, and that smoothed over the area. And since then, there have been more impacts, so we do see a few craters there, but all of the ones that came before that have been filled in and covered up, and that's why this area doesn't seem to be as heavy in craters, because we had these lava flows. And there are no more active lava flows on the moon. Those ended about 3 billion years ago. And so these are pretty old lava flows. All right. So heading now to our next planet. That is the planet Mars, the red planet. So called because, it's red. That red color that we see actually comes from rust, iron oxide, that is all over the surface, and that gives it that rusty reddish-orange color. Now, Mars doesn't really look like the Earth, and it's much smaller than the Earth. A lot of people don't realize this, but Mars is actually about half the size of the Earth. But what's interesting is with Mars, we have an overwhelming amount of evidence that suggests that Mars was once very much like the Earth, that it was covered in liquid water. In fact, and I don't know that we can see them super well with this image, but when you look closely at Mars, you can see areas that look like dried up riverbeds, that look like river deltas, water channels, shorelines. We think that there was a lot of water on Mars. And that's one of the reasons we are still so interested in studying Mars and why we've landed yet another rover on Mars, because where there's water, there could be life. And so we're really curious to see if back then, when Mars was Earth-like, if life was able to develop there. Now, obviously, something had to happen for it to no longer be Earth-like, and that comes back to it being about half the size of the Earth. Because it's smaller, it doesn't have as strong of a gravity as Earth, and so it wasn't really able to hold on to much of its atmosphere. And atmospheres act like blankets. They keep the surface warm. And so without that thicker atmosphere that it had early on, but wasn't able to keep a hold of, the temperatures started to plummet. And all of that water, or at least most of it, froze underneath, under the ground on Mars. And so we still see a lot of water ice all over the surface. but not really any liquid water anymore. So also on Mars are a couple of cool features, and it looks like they're in the nighttime side. So I'm just going to speed up time just a little bit until they are visible. And so the first thing is this big guy. This is a volcano. Mars has volcanoes, and it was volcanically active. We are not sure if it is anymore. There's still some research going into that. And I think Lindsay and Eli, you may remember, I want to say in the past couple months, there's been some reports coming out that suggest Mars is still volcanically active. But I think there's still kind of a big question mark there. We're not quite sure. But this volcano that we see here is the largest volcano on Mars, and in fact is the largest volcano in the entire solar system. This is Olympus Mons. This volcano is so big that it would cover the entire state of Arizona and sits 3 times taller than the tallest mountain on Earth. It is a truly massive volcano. And then right next to it is a huge canyon, Valles Marineris, which puts our Grand Canyon to shame because this canyon would stretch across the entire United States and at places is 3 to 4 times deeper than our Grand Canyon. So Mars, for being, a smaller planet, has some pretty big features. Mars also has a couple of moons, Phobos and Deimos, although we think they're actually captured asteroids, so they don't look quite like our moon. They're very small, irregular shaped, and we think they're captured asteroids. All right, so moving on away from the inner planets, we are going to head out to Jupiter, the king of the planets, the largest planet in our solar system. So big that it would take about 1,000 Earths to fill it up, and looks pretty different. We see just these beautiful bands of clouds across its surface. Underneath those clouds are more clouds, but then going under that, the entire planet is actually not gas. I know Jupiter and the other outer planets are often called the gas giants, but that name is a bit of a misnomer. It's not correct because the bulk of Jupiter is actually a liquid. Now, it's not liquid water, it's liquid hydrogen, but it's still a liquid, and so it would probably be better to call these liquid giants instead of gas giants. But on the surface, we do see this outer layer are gas clouds, just like clouds we have here on Earth. They're not made up of exactly the same thing. The clouds that we're seeing here are made up of different types of gases. But yeah. Now, the most famous feature on Jupiter is this big red spot that is literally called the Great Red Spot. Astronomers are not always clever when coming up with names. But this Great Red Spot is a hurricane. But much, much worse than any hurricane we have on Earth. This hurricane could fit 2 to 3 Earths inside of it. And it's been going on for over 350 years. Basically, as long as we have been looking at Jupiter through a telescope, we have seen this storm here. And we're not entirely certain why it's been able to last for as long as it has. There's some hypotheses that maybe because there's no land. We know that hurricanes on Earth lose their energy when they move from being over the ocean to over land. And so maybe because there's no land, it doesn't lose its energy. But that's still a question that we're trying to answer. Now, surrounding Jupiter, you can see a whole lot of these like greenish teal lines. And these are actually all orbits of moons around Jupiter. Jupiter has 79 moons. Now, most of these are like Mars's moons. We call them lumpy space potatoes, captured asteroids, things that just got a little bit too close to Jupiter, and Jupiter's gravity grabbed onto them, and they started circling around Jupiter instead of circling around the sun. But Jupiter does have quite a few interesting moons. And while we do have a whole other show where we do a deep dive into many of the moons in our solar system, I do want to point out one of them. And I actually give me
While you're
one.
working on,
Yeah.
got a question. How fast is the Great Red Spot moving? It's around like 300 miles an hour, right? That's the wind
Yes.
speeds on it.
Yeah. Oh, he knows that. That was a problem that my students did in one of my astronomy classes. That's why he remembers that.
Yep,
I'm assuming that's why you remember that.
that is why. I remember the picture where like one of the spots on the outside of the storm was labeled, and we had to like look over time where how far it had moved.
Yep.
Yeah, that was cool.
Yep. That was one of the labs y'all did. All right. So the moon that I want to take a look at is Europa. We're looking at it now. This is, I would say, one of my favorite moons in the solar system, one of my favorite objects in the solar system. Although it doesn't look that interesting right away. We see a surface of ice. That ice appears to be kind of cracked, almost like maybe a giant's been ice skating. But what we're actually most interested in is not what's on the surface. It's not this ice. It's what lies underneath that. Because underneath that layer of ice, we think is an ocean of liquid water. And not a tiny ocean either. We actually think the ocean on Europa contains twice as much water as we have on the entire Earth. That is a huge ocean. And that makes us incredibly excited because where there's liquid water, there could be life. So there could be little alien fishes swimming around in this ocean underneath the icy surface of Europa, and we are trying to find out. NASA and other space agencies are working on future missions that will travel to Europa, land on the surface, melt or drill through that ice, and explore that ocean below. And let us know if there are, in fact, alien fish out there. Now, there is a lot that's going into this. There's going to be a lot of kind of recon missions first before we even land. And then once we go to land and explore, there's a lot that's got to go into that as well, including making sure that we are not bringing any sort of contamination, any type of bacteria or anything from Earth could destroy whatever ecosystems may be in that ocean. So there is a lot of careful planning that's got to go into this. But they are working on it, and I'm excited, and I want them to get it done in my lifetime because I want to know that there are alien fish. I have to know. All right. So let's head on to our next planet. Leaving Jupiter, we are going to head on over to Saturn. Saturn is, of course, best known for its beautiful rings, although it's not the only planet to have them. Jupiter, Saturn, Uranus, and Neptune all have rings. Saturn's are just the biggest and the brightest, and so they're the only ones that we can see well from here on Earth. So they were the first discovered, and that's why Saturn's kind of most well known for those. These rings, although they may look like they're solid, aren't. They're actually made up of millions and millions of pieces of ice. And that gives us a clue as to where the rings come from. Some of the little pieces that make up the rings are probably pieces chipped off from the many, many moons that surround Saturn. I mean, we can see a lot of them. In fact, Saturn actually has 82 moons, more than Jupiter. But we think the big ring system that we see is a temporary enhancement that a comet, which is a big ball of ice, got a little bit too close to Saturn, and Saturn's gravity literally ripped it, shredded it into lots and lots of tiny pieces. And those pieces are what make up Saturn's rings right now. And so we think that one of the reasons that they are so big and bright is this kind of temporary enhancement they have from this destroyed comet that got too close. All right. Saturn, again, lots of moons. There's quite a few interesting ones, even one similar to Jupiter's moon Europa. Saturn's equivalent is Enceladus, and it's another one that we think is a water ocean beneath the surface, which is, again, exciting. Another place that we could potentially search for life. All right. Heading on to our next to last planet. The planet with the funny name is Uranus. And this is always where the kids giggle, and it's okay, go ahead and laugh. But I have to tell you that this wasn't always its name. So this planet was discovered in, I think, the 1800s, and Lindsay, you might remember more than me. But it was discovered by an astronomer, William Herschel, who decided to name it after the King of England at the time. And so the planet, when it was discovered, was named George. Yeah. And it was, William was pretty smart because, you name a new planet after the king's going to really like you. And he ended up getting a lot of money from the king because of that. But all of the other astronomers, particularly those that weren't English and didn't serve the English king, hated that there was a planet named after King George. And so after many years of debate, they decided to rename it Uranus. And they picked it because Uranus is one of the Greek gods. And it fits the theme of the planets being named after Greek and Roman gods. And so that's how that all came about. We can see it looks kind of plain and ordinary, a bluish green color to it. And that blue is actually from methane that's in its atmosphere. But what's also interesting is Uranus is literally on its side. It's kind of like rolling around the sun like a ball. And we're not quite sure why, but our best hypothesis, which is my favorite, is literally something big ran into it and knocked it over. And that's why it's on its side. All right, we have one last planet to go visit. The furthest planet from the sun is the planet Neptune. Again, that really pretty blue color that we see from the planet is from methane, just like on Uranus. But we see a bit more detail in its clouds, a bit more structure there. We can see these whitish clouds. These are really, really, really high clouds that are actually methane ice clouds. But we also see that Neptune has its own little storm. It's the size of the Earth. So these storms are not just prominent on Jupiter. We see the other outer planets have them as well. There's a bit of mystery about Neptune's storm, though, because recently, although I don't think it's recent anymore, I think it's within the past decade, because time is passing and I don't like it. But in the last decade, we have noticed that Neptune's storm has disappeared. And we don't know if it actually has disappeared or maybe it's just moved below the kind of top level of cloud, so we just can't see it anymore. But there's some research going on into why it seems to have disappeared and may not be as long-lived as Jupiter's storm, although we don't actually know that because we don't know when both of them formed. So just some fun stuff that we're still trying to figure out. Unfortunately, we don't have a lot of information on Uranus or Neptune. Because they are the furthest planets away from us, they're incredibly difficult to study from here on Earth. And we've only had one spacecraft that flew past them, and that was Voyager 2 back in the 1980s. So there's a lot that we still want to learn about these planets, and we really need another mission to go out and study them up close. But that is the last of our planets in our solar system. Did we end up with any other questions, Eli?
Yeah, I'm actually doing a little bit of research right now. We just got, was that the King George who went a bit mad and was married to Queen Charlotte? And I actually am not up on my European history, feudal history, so I'm doing a little bit of research right
Yeah,
now.
I'm not sure which King George it was.
It was King George III.
Okay, cool.
I'm reading about him. Yes, it was the King George that was married to Charlotte of Mecklenburg-Strelitz. And yes, this King George did go a little mad toward the end of his
All
life.
right. I wonder if that also contributed to them wanting to rename it.
Yeah. Yeah,
That's really
I'm
cool.
looking at what he went blind with cataracts and was in pain from rheumatism. And he developed dementia in old age.
All right.
Hmm.
That was cool. Hey, we learned something. I like
Yeah.
that. All right. Let me not pin myself anymore. There we go. If anyone else has any other questions, now's a great time to leave them down in the comments so we can answer those. I always like doing these solar system tours, but I always feel like I want to run like super long with them because I just have so much that I like talking about. I
They
know
always seem
that's,
in the planetarium.
yeah, and I know that's one of the reasons like we have a separate moon show because if we were to include all of that, it would be over an hour for sure. But yeah. Um okay, so we just got another question. Does
Does
the
the storm on
storm or no, you go ahead.
Yeah, does the storm on Jupiter move around?
Yes, it does. Yep, the storm itself spins just like hurricanes do, but it also moves around Jupiter as well. Yep. So it acts pretty similar to hurricanes. I think the other big difference is it's a high pressure system, where hurricanes on Earth are a low pressure system. So it spins the opposite direction that hurricanes do because it's high pressure instead of low pressure, but that's maybe getting into a bit more detail. Yeah.
Astrometeor
Huh.
Astrometeorology.
Yeah. I mean, astronomy, that's like one of the great things about it is it's encompasses so many other disciplines. Like it's not just physics, it's biology, chemistry, geology, meteorology. I mean, it's everything. And
Oh,
I love it for that.
actually, I shouldn't say astrometeorology because that's a different thing. It's a science that attempts to forecast the weather using astrology. So no, that is not astro.
Okay. I did not know that was I guess I shouldn't be surprised that that's a thing.
Oops. Not astrometeorology. Is the storm moving clockwise or counterclockwise around the planet?
I don't remember because the different stripes that you see on the planet, at each of the borders of the different color stripes, the winds switch directions. And so you actually have a bunch of parallel wind streams that switch direction at every kind of color change, every band change. And so for the storm itself, I don't remember there which way it's moving.
It is moving horizontally. Well, I mean, I
Mhm.
guess that kind of subjective to what angle you're viewing the planet from, but
It's
it's
moving parallel to the equator.
right, right. But I think remembering back to the lab that we did, I think it's moving counterclockwise. If like north is at the top and south is at the bottom, if you're looking at it that way, I think it's moving counterclockwise.
Yeah, I don't remember. But I know recently um, studies with the Juno data showed that even though the appearance of the size of the storm appears to have been shrinking, the strength of the storm is actually increasing, it's actually getting stronger. And so it's interesting. They're trying to figure out why its outward appearance looks like it's getting smaller, but the storm itself is actually getting stronger, and where all of that extra energy is coming from. So there's some really cool mysteries, even just within our solar system, which is why we keep exploring it.
It is moving counterclockwise.
Okay, there you go. All right. Well, I will give a few more minutes to see if any other questions come in. We've had some really great ones tonight. These have been fun. And while we see if there are any others, let me tell you about what's coming up over the next week. So next Wednesday is going to be another edition of Ask an Astronomer. So we will be here answering whatever questions you have, whether it's something you just want to know or maybe you want to try and stump us. Although I will admit we do use Google sometimes to help us out. We don't know everything, and that's okay. I think that is perfectly fine. But we're going to have Ask an Astronomer next Wednesday. We'll also talk about some current events that are going on in astronomy news as well. And as I've already said, next Saturday is the next edition of our exploration series. We'll be taking a close-up look at the planet Venus. All right. Well, I think we will conclude it there unless any other last-minute questions come in. I want to thank everyone for joining us tonight. I know the weather is we're getting into the good weather part of the year. Um, so I appreciate those of you that still come to hang out with us during our streams, or if you're watching it afterwards, after we've, because you can, we always have these videos up on our Facebook page and our YouTube page as well. So just thank you to everyone. And yeah, I think we will call it a night there. So enjoy the rest of your weekend, and we will see you next time. Bye, everyone.